Hey guys! Thank you so much for keeping an eye on our channel and follow our free training series on ETABS. Today you're in for a treat. We will be discussing some features that can be considered a bit advanced, but we'll go step by step with you along the way, and we promise you'll not only just be able to follow the contents with ease, much more than that, you'll develop valuable new skills, which will empower you, and are sure to give you a competitive edge on your workplace. So just please stay with us, and if you're new here, consider subscribing. Following up on our previous session, where we had the opportunity to revise the EDB and E2K ETABS working files, and delve into how to work with stories and grid systems, today we will be exploring the features offered by our interactive database. There's a lot to discuss, even if this can be considered only an introductory presentation of the feature. Let's jump into it. On this chapter you'll have the opportunity to explore how to work with the interactive database. We'll start with a quick introduction, to help you understand purposes and advantages of reverting to the interactive database. We'll proceed our revision of this feature, by exploring the list of available tables, which should help in getting you familiar with both the interactive database, and the ETABS user interface in general. We'll then illustrate how to use the interactive database with step-by-step worked examples, including how to add a section property using the interactive database, how to add multiple sections using the interactive database and Excel, how to change section properties through the interactive database, how to add loads to frames through the interactive database, and how to add frames through the interactive database. Let's get started. Having covered how to start a model, saving it, and defining its corresponding stories and grids, today we will continue to cover some of the most important commands offered under the Edit menu, starting with the interactive database. This being only the third lesson on our training series, we were slightly reticent to introduce you to the interactive database this early, once it can be somewhat considered a bit of an advanced feature for the inexperienced user, especially if you are also just now starting to familiarize yourself with the ETABS user interface workflow. With that in mind, we should stress that, though we strongly believe that being aware of the existence and potential of the interactive database from an early stage, for normal daily basis tasks, you will more often than not rely on the commands of the ETABS user interface to add the input data, rather than refer to the interactive database. By end of this topic, you should have a clear idea on which situations it makes sense to revert to the interactive database, instead of adding or tweaking the data directly on the graphical user interface. Though at this point, this is only a preliminary introduction of the command, we cannot stress enough its importance. From joint coordinates, to materials, sections, loads, etc., here you find the complete list of input tables, that combined together represent your entire model. We'll definitely have the opportunity to explore the interactive database in more detail throughout the course, but just to give you a flavor of some of the operations that can be performed over the tables displayed on the interactive database, these include adding data either directly on ETABS or using Excel tables, coupled with copy-paste operations, thus drastically expediting input data operations, while also avoiding human error. Particularly useful, when adding repetitive information, for instance when you have to add several sections where only the dimensions are changing. It also allows to populate tables for the objects selected on screen only, and easily perform changes to those objects. For example, you can use this to change object sections, load assignments, etc. This is a very powerful command, as it basically allows you to control and manipulate all the input data of your model, in a very expedite way. The tables are populated on the fly inside the user interface, but they can also be exported to Excel, where large quantities of data can be manipulated more easily, and then re-imported to the software. After specifying that the information is to be applied to the model, ETABS will update the model accordingly. Looking at the complete list of input tables for the first time can seem a bit daunting, so please don't be immediately put off by the large number of model definition tables available here. Once you start using the software on a regular basis, you'll see as looking for a particular table on the list will become second nature to you. In fact, you can count yourselves lucky. Back in the old days, this information in an editable format could only be accessed via text, using the E2K text file. We've come a long way since then with the interactive database. Let's quickly go over some of the available tables, and point out the ones you will probably use more often. Under the System Data node, it's worth mentioning the tables for grid layout. If you're thinking that a table with the stories information should be available here, then you're correct. The reason that table is not there yet, is that the interactive database feature was actually inherited from the SAP 2000 program, and in all the portfolio of CSI software, only really ETABS recognizes the story concept, which explains why CSI hasn't yet added the stories information table here, but I gather we might be seeing it available in a not-so-distant future. The property, load pattern, load cases, and other definitions nodes list tables for which corresponding commands will be found under the Define menu on the ETABS user interface, and refer to definition of the analysis model, including structural properties, loads, analysis and combinations. It is under the Property Definitions node that you'll find all of your property definitions, including those of the materials and sections of all your structural objects, such as frames, tendons, areas, links, etc. The Load Pattern Definitions node embeds the tables with information related to the load patterns, plus the tables with the information of any functions required for different types of dynamic analysis, including response spectrum, time history, power spectral density, and steady-state functions. Under the Other Definitions node, you'll find some important tables, including the table with information of user-defined groups of objects, rigid and semi-rigid diaphragms, mass source required for modal analysis, and the tables for pier and spandrel label definitions. For those of you that are new to the software, piers and spandrels are a commonly used terminology in ETABS, referring to special automated section cuts, specifically used to check analysis and design results of shear walls. The Load Case Definitions displays the tables related with the definition of the analysis cases currently available on the model. At the moment the program lists only two types of analysis, those being linear static, in use for the default self-weight or dead case, and a default modal analysis based on eigenvectors. When other types of analysis are added to the model, this list will expand to accommodate those. Just to list a few other types of analysis that you can expect to see listed here, these could include, for instance, nonlinear static, nonlinear staged construction, response spectrum, time history, etc. If any design load combinations have been specified on the model, then the table including the combinations, listing the loads, combination factors, and type of combination, will become available under this node. Understanding the connectivity data node is of paramount importance when operating a finite element program like ETABS, and it refers to how the elements of the model are linked together at joints, to represent the structural system. In a finite element model, the structure is discretized in a finite number of deformable elements of finite size, connected together at rigid joints. In ETABS, joints are rigid points in space, and the elements can be of one or two dimensions, those being respectively frame and area objects. As a reminder, on our previous lecture, we introduced you to the global coordinate system, and clarified that ultimately all locations on the model are defined with respect to the global coordinate system. With that in mind, it makes sense for the first table displayed under the connectivity data node to be precisely the point connectivity, which lists the IDs of all the model joints, together with their global x, y, z coordinates. The beam, column, and floor object connectivity tables provide the IDs of the objects, together with the list of joints that are part of each object. It's important to stress that all objects on the finite element model, including joints, frames and areas, can be designated either by their non-editable labels, and by their editable unique names. Though ETABS assigns default unique names to every object of the finite element model, once they're editable, it means the unique names can be user-defined. Please notice as the connectivity tables always use the unique names, to identify elements and their corresponding joints. The beam, column, and floor object connectivity tables can also be referred to as connectivity matrices, and will later be used by the program to define which elements share the same joints and edges, which is important for ensuring continuity, stress transfer, and correct assembly of the global stiffness matrix. The joint, frame and area assignment nodes of the interactive database include tables for which corresponding commands will be found under the Assign menu on the ETABS user interface. For each object type, that is for joints, frames and areas, the user will be able to separately specify assignment of properties and loads. The property assignments depend on the type of object. For example, to joints, user can assign support restraints, whereas to frames and areas, user can assign a section and corresponding material. Under the Options and Preferences data node, you'll find a number of tables that are related with commands, available under the Analyze menu of the ETABS user interface, including the table that controls the degrees of freedom available for the model. The Sapphire Options table, which gives information on the solver and analysis process options. Tables with model settings for floor and wall meshes. And cracking analysis options for slab deflection analysis. Lastly, of interest, we could perhaps also refer the tables that include the design preferences, with indication of the predefined design codes in use, to design the different structural elements, that is, beams, columns, slabs, shear walls, etc. As nothing really helps as much as a quick example, let's perform a couple of model editing operations using the interactive database, just to make sure you fully grasp how to make the most out of this feature. Adding a concrete rectangular section is probably one of the simplest operations you can perform with the software, so let's use it for our first example. In your daily basis work, you'd most probably add it through the ETABS user interface, using menu define, section properties, frame sections, add a new concrete rectangular section. Besides other parameters which are unimportant for our first example, you'd need to specify a name for your section. Let's call it C30 by 30. Assign a material, which can be this default concrete C3037, and specify its dimensions, 300 by 300 millimeters. This same operation can also be performed using the interactive database, which, depending on the situation, can be considered a more expedite alternative. Start by exposing the table for the frame section property definitions, for concrete rectangular shapes, found under the Property Definitions, Frame Section Properties node. With the table populated on screen, let's revise the options given as command buttons on top of the table, which are as follows. Copy selected cells. Paste. Paste insert. Paste append. Delete row. Append blank rows. Find. Replace. And export to Excel. Click the Append Blank Rows button to add a new line at the end of the table. Select the information on the first line of the table, and hit button, Copy selected cells. Then select the line just added to the table, and paste the information. Please note as this will duplicate the section from line 1. If you leave it as is, meaning, without changing any input data of the additional section, the program will just basically ignore the newly added line. If you keep the name of the section, but you change any other input data, say for instance changing the material to one of the other default materials of the model, such as the steel S355, then the software will update the data of the existing section, while keeping only one section C30 by 30. This to say that the software will never allow duplicating two items of the same type with the same name. You can confirm this by checking that only one section C30 by 30 is listed on the available frame section properties on the interface, and that it has material S355 assigned to it. And by repopulating the table on the interactive database. Please note as now only one section designated C30 by 30 is listed, and that assumes the latest assigned material S355. Please note that, though we are using the example of a section property, the described assumptions made by the interactive database when adding new data with duplicated names, apply for all other definitions, such as materials, loads, elements, etc. Now let's revert the material back to concrete C3037, and add another copy of the section, but now let's use it to actually define a new section property. Having a different name is enough for ETABS to create a new section, even if all the other input data is the same. Only the name must be different. In our example though, besides the name we are also revising the section dimensions, which are now 300 by 400 millimeters. All the other input data is the same as that of the original section. Click the Apply to Model button, and then check the revised list of available rectangular sections, in order to confirm that the new additional section has indeed been added to the model. In fact and as expected, now both sections C30 by 30 and C30 by 40 are listed, both with material C3037, and their corresponding dimensions, as specified on the table of the interactive database. Please notice as, for each section property, considering the dimensions specified for the section, the program is able to calculate the geometric properties automatically, including area, inertias, shear area, etc. With that in mind, let's now assume we need to add 100 additional rectangular sections, where only one of the dimensions is changing, all the other data is the same. Instead of manually adding them one by one on the interface, let's use the interactive database and export the concrete rectangular frame section properties table to Excel, where we can add the information in a more expedite way. Click the Export to Excel button. Excel will launch automatically with the table populated on screen for you. Copy the section property just defined using the interactive database, the C30 by 40. You only need the name, material and dimensions. These are the basic parameters required for the program to create the new additional sections. Let's leave all the other input data in blank for now. For illustrative purposes, let's proceed from the assumption that the width is the dimension changing, and is now 50 centimeters for this new section. As stressed a few moments ago, make sure to also change the name of the new section, if you want to avoid the data being ignored or incorrectly assumed. You can now extend this information to represent the number of additional section properties you want to add. Let's imagine these represent the 100 additional sections mentioned earlier. As you can see, the only information added for each new section property is the name, material and dimensions. Now let's revert back to ETABS and hit the Retrieve Information from Excel button. Notice as the information is populated from Excel into the ETABS database. Hit the Apply to Model button. The interactive database import log is displayed, with important information of any warnings and possible import errors. In our particular example, these are only warnings related with the parameters we left with blank information, and the program is indicating that for all these data, default values will be used, but be mindful of any possible import errors. If any are listed, user is advised to carefully revise them, and apply any remedial measures as deemed fitted. Once again, visit the Frame Section Properties definitions on the ETABS interface, and confirm all the additional sections were correctly imported from Excel. And each of them with all their new names and corresponding dimensions. Moreover, all the geometric properties of each of the new sections are calculated automatically, based on each of the section dimensions. Having illustrated how to use the interactive database to add several additional section properties into the model in one go, combining the use of the interactive database with Excel and copy-paste operations, on this next example, we'll show how to change element section property assignments. Start by using the Model Explorer, Display tab, to check that all the columns on the model currently have section property concrete column 1 assigned to them. Now use the Model Explorer, Model tab, to select all the objects with this frame section, which basically allows you to select all the columns of the model. With the 64 column elements selected, let's revisit the interactive database again. Please notice as the checkbox selection only is ticked, which means that the tables will only list selected elements. Choose the Frame Assignments node, Frame Item Assignments and expose the table of the Frame Assignments, Section Properties. Now revise the section property of the elements listed, from concrete column 1 to column 30 by 30. You can use the copy-paste operations offered on the interface, to apply these changes to all the elements on the list. Hit the Apply to Model button. Check as the column sections have now been revised, and are now all columns 30 by 30. Having covered how you can use the interactive database to add additional properties to the model, and to change property assignments, the next example illustrates how to use the interactive database to add loads to the model. When you start a model in ETABS, besides the self-weight or dead load, the program also includes a default live load. You can check this under the Model Explorer, Model tab, Loads node, Load Patterns list. At the moment, once we haven't assigned any loads to the model using this load pattern, the live load is not in use. Let's use it to apply some uniformly distributed loads on the perimeter beams of the model. Start by assigning the load to a beam element the traditional way, that is, selecting the element, and using Menu Assign, Frame Loads, Distributed, and for the live load, you can specify the direction and intensity of the load, let's say 5 kN per meter in the gravity direction. Please note as the load is displayed on the graphical user interface. We actually had a somewhat ulterior reason to add this first load to the beam on the interface, rather than immediately show you how to add it using the interactive database, and that is the fact that for the Frame Distributed Load Assignments table to become available here, at least one frame distributed load must be assigned to the model. Otherwise this table wouldn't be displayed under the interactive database. This to say that the interactive database only lists the tables, for which data exists at list for one line. In other words, unless the option Expose All Input Tables is checked, empty tables will not be available by default. A good example of this, which we actually had the chance to mention briefly earlier on the video, is the Design Combinations table, which we mentioned would become available under the Load Cases Definitions node. As soon as you tick the box Expose All Input Tables, then you'll be able to see the table on the list of the interactive database tables, but if you expose it, it will be empty as expected. Reverting back to our example, if you expose the table of the Frame Distributed Load Assignments, you'll see that there's only one line, listing the information of the load just applied using the user interface, to beam element with unique name 65. If you right-click on an object on screen, you can check its label and its unique name. The latter can be user-defined. As a reminder, the interactive database uses the unique names when referring to any object on the model. What we want now, is to apply this same distributed load to all the beams on the model. Once we don't know their unique names, and even if we did, we wouldn't want to have to add them one by one on the table. What we can do is starting by selecting all the beams on the model, and then apply the load assignment to the selected elements only, in a similar fashion as done on previous example to assign a frame section. Start by checking the section assigned to the beams, using the Model Explorer, Display tab, and under the Options, Frame Assignments node, expose the sections. Confirm that all the beams on the model currently have section property concrete beam 1, assigned to them. Revert back to Model tab of the Model Explorer, and select all the elements with section property concrete beam 1. This will allow you to select all the 48 beam elements of the model. With the element selected, let's revisit the interactive database once more. Please notice as the checkbox selection only is ticked, which means that the tables will only list selected elements. This time, to help us with the identification of the unique names of all the selected beams, we need to expose the beam object connectivity table. And then to assign the loads, you need the frame load assignments, distributed loads table. Start by exposing the beam object connectivity table. Confirm that it lists 48 lines, corresponding to the 48 beams selected. Notice the first line is for the beam with unique name 65, which is the one to which we already assign the distributed load. Copy the unique names of the remaining 47 beams. Export the table of the frame load assignments, distributed loads to Excel. Paste the unique names previously copied from the beam object connectivity table. Use copy-paste operations to replicate the 5 kN per meter live load on each beam. Import this information to the ETABS database, and apply to model. The program immediately updates the 3D view, now displaying the load assignments for load pattern live. This operation concludes this example. Lastly, having covered how to add properties and loads, for our final example, we want to show you how you can refer to the interactive database, and use the connectivity data tables to add objects to the model. To illustrate this, let's add an additional beam element. For simplicity, we'll use joints that are already part of the model. Start by preparing a plan view of one of the stories. You can use the Model Explorer to display the joint unique names. Once now you already know that the interactive database will refer to those, when populating the tables. Let's use joints with unique names 12 and 22 to add an additional beam under the beam object connectivity table. Start by populating the beam object connectivity table of the interactive database. Let's try and keep the joints in view, so we have their unique names handy. Browse to the bottom of the table and append a blank row. As a reminder, unique names can be user-defined. Let's call our test frame, simply frame. Specify the start joint as 12 and the end joint as 22. Hit the Apply to Model button. The program immediately displays the newly added beam element. As a last step, you can check its unique name. This concludes our revision of the interactive database. We hope this was enough to give you a sense of the operations you can perform with this tool, and the advantages it offers when manipulating large quantities of data in one go. Thank you so much for watching. If you liked this video, please don't forget to give us that thumbs up, so this video can spread to more people. If you want to check the next video on this series, you can visit it here. Check out our website, structuralacademy.com, for additional information on all the other courses we offer. And stay tuned on our channel for all our latest content.